Okay. So I'll be presenting about FlanT5 today. So basically, what is T5? T5 is a language model which had been developed by Google years back. T5 can be used for a lot of NLP tasks. The basic architecture of a T5 is encoder decoder. I think it has around 12 blocks of transformer in it. And it is not like the other models like BERT, which only has encoders, or GPT, which only has decoders. Now coming to FlanT5, what is FlanT5? FlanT5 is basically T5, but it is actually instruction tuned on other set of tasks. So there are a lot of tasks which we'll be discussing later on. So yes, so these set of tasks, okay, no. First, let us discuss how this instruction tuning has been done. So the Google developers, they actually took into consideration 5 different points for instruction tuning. The instruction tuning for the first point, that is, they actually took around 1800 tasks, that is around 1836 tasks, to instruction tune that model, in addition to some of the chain of thought reasoning data. They also took into consideration some of the input inversion data to add to the data sets. Now, what is input inversion data? Basically, input inversion data, you can say it as like, let's say you have a question, then you want your model to generate some answer along with the chain of thoughts reasoning. So it's basically assuming a few more permutation of the orders of that data. That is, you can just give the model let the model learn what the chain of thought reasoning is, and then let it understand or predict what your question and answer can be. Similarly, you have the answer, you can ask your model what your chain of thought reasoning and what the questions can be. And then the Google developers, they considered not just 0 or few shot prompts to train their model, but also a mixture of 0 and few shot prompts. And the last thing is they considered balancing mixtures, in which they considered like what proportion of the set of tasks that can be used to train their model. So it can be either equal proportions of all the set of tasks, or let's say they drop out one of the set of tasks and consider the rest of the things. Now coming to the previous model, it will be now easier to understand what instruction fine-tuning is. So instruction fine-tuning right now is you give the model an instruction. For an example, you tell the model that classify this review. You have the review as I love this DVD. So the model, so if you have an example saying that the sentiment is positive, and you have a subsequent example like I don't like this chair, the model now it makes it easier to predict that the example is of a negative sentiment. And okay, so these are the various set of tasks which was used to actually instruction fine-tune the FlanT5 model. So previously I said there were around 1800 tasks. So I think if you sum up all these, the T0SF, the natural instructions V2, the chain of thought reasoning, and the muffin, it should sum up to something around the 800 tasks. I think that's 1836. And then we also have a few held out tasks like the massive multitask language understanding and the big bench hard tasks, and a few other multilingual tasks. These tasks are like, they were not taken into consideration by fine-tuning the model, but they were used to evaluate the FlanT5 later on. And here we have a table that actually represents the results. So we have the T5XL FLAN model, and then we have the list of methods that are listed down. After that, you can see there are a different, like separate, some other models, the base T5 model, like fine-tuned on some other set of tasks. Then we have some other models as well, like the OPT IML Max. So first of all, let's compare, like take into consideration the accuracies for the FlanT5XL model. If you look at that and then compare to the next part, that is where the chain of thoughts, input inversion, mixture balancing, and the few shot templates is written, you can see, like, if I remove any one of those methods, the accuracy or the performance of the model instantly drops. And then in the subsequent part, we have the other models. There also, the accuracy is not as high as the FlanT5 models. So the result depicts that the FlanT5 models actually outperforms the other language models. And also if any of its methods are dropped and not all of the methods are taken into consideration. And this diagram basically represents the mixture of the zero shot and the few shot templates. So one of the conclusion of this paper was if you consider a mixture of both the few shot and the zero shot templates, the model's performance is actually better rather than considering just the zero shot templates or the few shot templates. So if you see, like, if you just for the first part, if you just see that if we increase 10% of the few shot templates, then the model's accuracy for the zero shot increases by around 2%. And yes, so that's the conclusion, that if you're just mixing them up, the performance goes up. Then instead of, another thing is, like, the FlanT5 is actually fine-tuned on a set of tasks. But let's say if you want to consider the base model T5, then T5 fine-tuned on a single task, and then FlanT5 fine-tuned on another single task, and then compare the performance of all the three models. So the developers actually did that as well. They found out that for all the set of tasks they took into consideration, the FlanT5 model, which was fine-tuned, let's say on any single task, there are so many tasks here, actually outperforms the other set of tasks. So in summary, we can say that FlanT5 fine-tuned on a single task is actually a better model and can be taken into consideration for any kind of research now, because we don't have access to large language models. And then, okay, and yeah, so this is another comparison between the FlanT5 model and the base model T5XL. Here also we can see that the FlanT5 model, like, it converges faster than the base model. And yes, so that's it, and it's a better model than the T5 base model.
So what's the difference between T5 and FlanT5 essentially?
Okay.
In the architectural goals.
In terms of the architecture, I find it's pretty the same. So I think the only difference is in case of the task that were taken into consideration, the different task and the different methods. These it was instruction fine-tuned on different things, and they like did rigorous amount of experiments. Like, there were a lot of experiments when you go through the paper. So like too many experiments were there. They added so many things. So basically it's like a better version of T5. Like, it has gone through rigorous training. It has knowledge, a lot of knowledge, but the architecture remains the same.
Okay. Okay. I see. So did they check any experimentation on how this model generates explanations? Or is the model's attention or focus is exactly what an end user wants? I think the data sets that they have used are pretty open-ended, right? They are not, let's say the COT data set, right? Explanation generations. The COT, I didn't see any performance improvement in their COT tasks.
I think, I think they did do some COT held out task as well.
Okay.
They have evaluated on that as well.
Okay.
So, yeah.
I saw the
because they are fine tuning with that, so they should be actually comparing that to evaluate the model's performance.
Any questions? This is worth checking out the COT reasoning task, Ali. If that category falls into your description.
Yeah, sure. I'll say that.
Right?
And nowadays people are using FlanT5 a lot. Like if
Yeah.
you check out any random course, they have an
I
exercise. with the
submitted an
questions.
article to a magazine and I had an opposite interpretation for FlanT5. My T5 Excel was better than FlanT5 by I did an evaluation with 45 experts and my results were like more favorable for T5 Excel than FlanT5.
But it actually says the
The opposite.
opposite here
That's what my
in both the cases.
intuition was. Like that's what I was asking the question. Like why is it so?
So here also, if you see, they have tested on a lot of benchmarks. There are so many,
Yeah.
and like they have actually compared
Did
the
they do it any
base
human
model.
evaluation or something? Or any evaluation that said that okay,
I don't think so. They did a human evaluation.
okay.
So basically, these sets.
So the thing is that
task
what I found in my experiment was the following: the T5 Excel was if I can make T5 Excel follow an instruction better than FLAN T5. Your FLAN T5 is already following so many instructions in the data sets. I'm this sentence I'm making based on my understanding of a PPT. Right? Let's say yeah, FLAN T5 was already on instruction tuned, right? It's already following in instructions. T5 Excel is not. Right? So if I'm making a T5 Excel follow as an instruction or guideline, it was able to follow it better than FLAN T5.
So that shouldn't be the case actually.
Yes. If it is adaptable, if FLAN T5 is doing so good job, then it should be adapt now. I'm not really sure. Like, okay, these data sets are improvement is good, but like if you see right, this improvement score that you're seeing over here are like okay, you're having a plus 4 points improvement over there, right? But when you look at it, it's very sensitive domains. These improvements are not worth the buying this model. I don't know whether like it's just my open thing. Like, when I read this, when I see a presentation, it seems like okay, there's no major difference between FLAN T5 and T5 Excel. Other than that, it's like I did on 100 tasks, you did on 200 tasks. Right? The architecture remains the same, right, Nilanjana? If architecture is same, then you can mess around with the architecture a lot more easy than just relying on FLAN T5. I think. If architecture is not different, then you can even extend your work on the T5 Excel. T5 Excel.
So the one of the things is like the T5 model has the encoder and decoder, both of those things. And if you have a encoder decoder, both of these things, I personally feel that that's a better model.
Yeah.
I feel that if the GPT had encoder decoder rather than just the decoder, the GPT would have been the chat GPT would have been a better model.
Exactly. That's why you do prompting, right? Because you don't have an encoder. Right? If you have an encoder model, then you don't need a prompting. Then you can train your model end to end. Good. Okay. So